this right here. So I gotta get the product of this mechanism, okay? So first, we need to substrate a tertiary alcohol. This is a tertiary alcohol that is gonna react with hydrobromic acid. This is hydrobromic acid. Okay, when a given tertiary alcohol reacts with HBr, is on molecular nucleophilic substitution is gonna take place. Okay, so the first thing that it's gonna happen is protonation of the OH group. When this happens, so the positive charge on the oxygen is formed. So the first thing we're gonna do is, I'm gonna write this down here. Let's go see it. Maybe more behind like that. Okay, perfect. So it's gonna separate the OH. So I'm just gonna write O here and the H here and all the molecules for O. So H is gonna leave and Br is gonna form, bromine. It's gonna form. Okay, which is gonna react with Br. And then we need to stabilize this intermediate with the loss of water. The molecule of water is gonna take place. It's gonna actually leave. So now we have to write here. And then we got OH. It's gonna leave here. It's gonna leave here. With the loss of water molecule, loss of H2O, we're gonna get the tertiary carbocation intermediate. Okay, and then the nucleophilic attack of bromide ion. Then it's gonna be hence this reaction in the OH group, the Br is gonna get in here, and then the Br, the bromine, is going to replace. So the OH group is gonna be exactly replaced by Br, right there. Okay, product. Okay, so this is the second question. Provide the reagents and show arrows wherever applicable. Prepare. So I have a cyclopentanol and it's gonna end up in a terbutyl, but I have to figure out how to get there. Okay, so the first step will be the protonation of the alcohol. So I'm just gonna write here, it's gonna go to, and then the second step will be the formation of the terbutyl carbocation. Okay, and then it's gonna be nucleophilic attack by protonated pentanol, and then CH3, and then the OH on this side, and then the fourth step will be the protonation, that it's when it's formed the H3C, CH3. Okay, so the reaction follows the SN1 unimolecular substitutions, and the terbutyl chloride forms an stable carbocation before substitutions. The alcohol must be protonated to improve its leaving ability, and the nucleophilic attack by pentanol leads to an ether formation, which is this one. Thank you. Okay, this is my third question. Let me just read it back to you. Explain the observations, use appropriate jargon, provide the product and mechanism for this mechanism, and find A through E. I have to find what's in there. Okay, so let me just go through with it. There are a few steps that we gotta go through. The first step is going to be I'm gonna draw benzene here. I don't know if you can see what I'm doing. Maybe take this off. Okay, perfect. Okay, we're gonna write here Br2 FeBr3. So this is bromine and iron bromide, and benzene is a stable aromatic compound. When it's reacted with bromine and iron bromide, iron bromide activates the bromine molecule to produce Br+, an electrophile. This electrophile reacts with the benzene ring to form bromobenzene. So we got this result right here. So Br. Okay. Then for the second step, we got so it's gonna be bromobenzene over here reacting with magnesium, which is going to give me. So in the presence of magnesium, bromobenzene turns into a Grignard reagent, so BHMGBr. So the result of this would be Mg magnesium bromine here. So bromobenzene form step 1 is reacted with magnesium metal to form a magnesium bromide compound, phenyl magnesium bromide. It is highly reactive nucleophile, and so the next step would be bromobenzene with the magnesium, which is going to react plus. Okay, with a formula of dihyde, and it's gonna react with H3O plus an acidic workup. Grignard reagent combines with formaldehyde to form a primary alcohol. Okay. Attacks the carbonyl, the Grignard reagent attacks the carbonyl carbon and forms an intermediate alkoxide ion. After an acidic workup, it turns into a primary alcohol, like so. Okay. And then for the last step, when the aldehyde reacts with amine, so like this, with amine, it forms a C double bond N, an amine compound. This reaction is called condensation reaction, in which water, H2O, is released as a product. So it's going to finish ending up like NH double bond C, like this. An acid catalyst. Okay. My motive point for this for today is gonna be about this question right here, and this: why does this follow an SN1 mechanism instead of an SN2 mechanism? The formation